see if this is going to fix. So the first step was to multiply everything by 36 to get rid of this fraction. And that would make this 36w squared minus, what was this middle term? Negative 84w plus 49. The 36 is canceled. And then that looks more like the trinomials that we were dealing with yesterday and the day before. And then this is where it gets a little tricky. I'm going to grab my calculator also. Because we had to multiply 36 and 49, and you got this huge number. And the other day I said usually when you have a big number there's a GCF, but in this case there's actually not one. So when you get something like this, and you have this huge number and you don't know the factors, starting small is probably not your best option. But I gave you that hint that you multiply 36 and 49, so probably start around there. So I'm going to look at my calculator and start dividing by, let's say, 37. Because I know 36 and 49 wouldn't, if I added them together, wouldn't give me 84. It gives me 85. It's close though. So I do that, I get a decimal. So then I'm just going to keep kind of doing this. This takes time, it's time consuming, but I'm going to keep doing this until I get a whole number. So I know it has to be somewhere between 36 and 49. 38 didn't work. 42 would work. 40 was close, but if I divided it by 42, I get a whole number, 42. And in order to make it negative 84, they would both need to be negative. So then once you get that number, that's probably the hardest part, finding your factors. Once you have that, then everything else is the same. 36w squared minus 42w minus 42w plus 49. Split that down the middle. What did these two have in common? Six. Keep going. I'm sorry, 6 was right. I was thinking about this one. 6 and w. So if we divide those both by 6w, what's left? 6w minus 7. And then what can we divide out of the last two? 7. Negative 7, though. Which will leave us with 6w minus 7. So 6w minus 7 squared was that final answer. Okay. These two I want you to write down, but this is for later practice. So write these down somewhere so that you have them for later practice. And then if we have time today or tomorrow while you're just practicing anything, if you practice these and need my help, want to check it, let me know. And then if you miss that answer, I'll scroll back up. So we have talked about all of the different ways to factor. Differences, GCF, difference of squares, your A equals 1, trinomials, your grouping with 4 terms, your A does not equal 1, what we were just doing yesterday, to include some things with rational fractions, rational numbers. Now we're going to do the last part of Unit 9, starting today, finishing it tomorrow, dividing polynomials. So this kind of goes back to our polynomial operations of last unit, but also not at the same time. And we're actually going to start on this page. So the warm-up problems are there for you to practice all the different types of factoring that we've been doing. So you could do those in your own time. As a reminder, you guys will have 3 delta maths due on Friday after this lesson. Your A doesn't equal 1, your mixed factoring, and then this one. That was the wrong page actually. It was this one, sorry. Okay. So we're going to start with the basic dividing polynomials by monomials, single terms. And you could do those one of 2 ways. One, you can divide each one separately. So in this one, I could separate this, rewrite it as 8t over 4 plus 12 over 4, and divide each one separately. And then if I do that, what would that be? 2t plus 3. That would be the answer.
So what if you get a decimal?
You're not going to get a decimal here. You might get fractions, and you need to leave it as a fraction, but no decimals. The other thing you could do is find the GCF of your numerator. So what do these have in common? 4. So if I divided them both by 4, what's left?
2.
Now, you did that, but this was already dividing by 4, so we can't leave that off. And then you could cancel out the 4s. You would get the same thing. So you have a choice. Some of these you may want to just do separately, especially if you start to find a GCF, but when you start dividing, it doesn't match up. That one, do separately. But some of these other ones, it doesn't matter. Okay, questions so far? Okay, we'll jump around. Number 3. We'll do both, and then after this, I'll let you guys choose. Kareem, can you open that door, please? Thank you. Alright, let's do GCF first. 5t, and usually whatever this is going to be your GCF, so that kind of helps you. So 5t, what would be left?
3t plus 4.
3t plus 4, and we're dividing all of that by 5t. The 5t's would cancel, just leaving us with 3t plus 4. You do still need to write that, your final answer, 3t plus 4. You can't just leave it in the parentheses. I need to know that you divided it all the way. If we divided it separately, I'll put that off to the side. We should get the same thing. 15t squared divided by 5t is 3t plus 4. So, either way.
So what happens to the square?
When we're dividing like bases, we're subtracting the exponents. Alright, let's jump to number 5. Do we want to do GCF or separate it? GCF, okay. What do these have in common? AB. Let's move this up some more. If I divide out AB, what's left? 8A plus 3B. Don't forget that you're dividing. You need to write that you divided by whatever. The AD would cancel out, leaving us with 8A plus 3B. Let's do 6. GCF or separate? Okay. So if we separate, write out each term. divide each one by 2t. 4t cubed divided by 2t. 2t to what power? Squared. Plus 18t squared divided by 2t. 9t. And negative 10t divided by 2t. Negative 5. So that whole thing would be your answer. 2t squared plus 9t minus 5. Question so far. Okay. Number 8. GCF or separate. Okay. What would be the GCF? 9 is part of it. A, and 1b. So if we divide that out of each thing, what's left? 2a to the 4th, b to the 4th, plus 5. A squared, b to the plus 1. So then our final answer would be 2a to the 4th, b to the 4th, plus 5a squared, b squared, plus 1. Other questions on this page? Usually, but not always. I was going to try and find an example where it's not. But I don't think that example is in here. So I would say if you start dividing the GCF and you're noticing that you're going to get negative exponents as you're dividing, then separate it. Scrap the whole GCF idea and just separate it and go like that, and then rewrite it into separated fractions. I thought I had an example like that, but I don't. Okay. Go back to this page. And with this, you'll see that we are now dividing different polynomials by binomials. So it's not going to work the same way we just did. With these, you have to factor the numerator and then cancel your like factors. So you have to be really good with your factoring methods, recognizing what type of factoring we're going to use. So with this first one, I have a trinomial. So we have two types of trinomials, a equals 1, a doesn't equal 1. Which one is this? A equals 1. There's an invisible 1 in front of us. So because it's an a equals 1, we're looking at two numbers that multiply to be 6, but add to be 5. So what are some factors of 6? 2 and 3, 1 and 6. I'm going to rewrite this under here. Which of those would add to be 5? 2 and 3. So I'm going to rewrite this whole thing. 1 with the factors. X plus 2, x plus 3, all over the factor that was already there, x plus 3. And then I have like factors. If I cancel them out, what's left? X plus 2.
Where'd you like you say A? Where's the A?
There's this. this is B, this is C. So when you see that format, the number in front of x squared is A.
So A would be in front of the first number every time.
And then depending on if you see a number or not, that'll tell you if it's A equals 1 or doesn't equal 1. Okay? Questions on how we did that? So that would be your final answer. All right, we'll do one more of those and then go on to another type. Number 2, this is a trinomial. So A equals 1 or A doesn't equal 1? A equals 1. So we're looking for two numbers that multiply to be 27. Okay. But add to be 12. I heard 9 and 3. And that would be the one that works. So if we wrote that into factors, what would that look like? Don't forget your denominator. Cancel out your like factors, and your final answer would be x plus 3. Show that you canceled out your like factors. So if you get an A equals 1 trinomial, and you recognize that it's an A equals 1 and recognize how to factor it, that should be fairly simple. Let's try another one. Number 4. Again, trinomial, A equals 1 or A doesn't equal 1? A doesn't equal 1. So what are the steps for that? What do we do first? Yes, but first, look for what? Look for a GCF. Does it have one? No. So do that first with everything. And now that we know it doesn't have a GCF, yes, multiply 6 and 5. We're looking for factors of 30 that would add to be 13, 15, and 2, 3 and 10. 3 and 10 is going to be the one that actually works here because we have all positives. What would be the next step? So not in this case. That's only when A equals 1. We have to rewrite it into 4 terms. So these type, you'll need space. So 6x squared plus 3x plus 10x plus 5. Don't lose that we're dividing each time. So in each step, rewrite that we're dividing. We're still factoring the numerator. What's our next step? That would just get us back here. We have 4 terms. We're now factoring by grouping. Splitting it. And after we split it, we do what? Divide by what? Find the GCF of each one, which would be 3x, leaving plus, and the next GCF, leaving 2x plus 1. Again, all still dividing. Don't cancel out your like terms here. Wait until you have final factors. So, next up. So when we write our final factors, what would those be? And then when we cancel out our like factors, our final answer would be. So those ones have a lot of work. because we have to factor everything and then cancel out the final answer at the end. Questions on that? We're going to try one more and then be done for today. Right, for number 5, we actually skipped 3, but that's okay. For number 5, this would be, how would we factor this? Using what type of factoring? What type of polynomial is it? Trinomial. So of our trinomial factoring methods, which one would we use? Say that again. We are going to look for a GCF first, but does A equal 1? No. So A doesn't equal 1. That's what we're doing here. Doesn't have a GCF. So then multiply 4 and 5. And we're looking for two numbers that multiply to be 20, but add to be negative 12. 10 and 2. And would that work? If we did what? Make them both negative. So if we rewrite that, we have 4x squared minus 2x minus 10x plus 5. What's our next step? Split it. And find, what is 2x? The GCF of these two, which will leave us with 2x minus 1. GCF of the last two, plus 5, negative 5. Which would leave us with, Kareem, are you writing this down? 2x minus, not 5, 1. There we go. Alright, almost there. Rewrite our two factors. What would those be? 2x. And if we cancel out our like factors, what's left? 2x minus 5. Tomorrow, when we do some more of these, I'm going to show you how you can check yourself in the calculator / in Desmos. And do some more of these. So, you have about 16 minutes left of class. You can keep practicing in these. You can work on Delta Math, JLabs, SOL practice, any of those.